Hello everybody, this is Mrs. Baxter, and today we are going to be discussing dividing square roots. And based on what you've learned so far with simplifying, adding, subtracting, multiplying, all three of those skills will come into play when we talk about dividing. Okay, there's some basic things that you need to know when we look at dividing by a monomial by a monomial. So what that means is one term divided by another term, very much like what you see in example number 1, which is a fraction. Now remember, we're going to do a quick review here on vocabulary. The number in front here is called the coefficient. Okay, so coefficient. Okay, the number inside is called the radicands. Okay, and let's see, all the other rules in terms of how you simplify also apply. Okay, now one of the key things with radicals is that you cannot have a radical in what we call the denominator. So it's called rationalizing the denominator, which is also the same as getting rid of the radical in the bottom of a fraction. So this right here is a no-no. This right here is a no-no. So what I'm going to do is teach you how to get rid of that today. All right. If the directions right here tell you to simplify, this implies or means that your answer should not have a radical in the denominator. Okay. So for example, let's look at example number 1. It says to simplify. We have square root 14 divided by the square root of 25. Well, here is the simple, easy, straight up here. Square root 14, if I try to simplify that, it becomes 2 and 7. There's no other number that can come outside, inside, so the square root of 14 is as simple as the top can get. All right, but now thinking about the square root of 25, if you happen to remember your square roots, you would remember that this is 5 times 5, right? So we have a pair. This automatically just equals 5. So this particular radical simplifies to square root 14 divided by 5, okay? I've simplified. I haven't really had to do a whole lot of anything else. All right, this is why it's helpful to know what some of your square roots are. All right, so this one's pretty straightforward and simple. Let's look at number 2. Problem number 2. All right, I've got 2 radicals on top of each other. Well, there's a nice rule that says, hey, we can, if we have radicals on top of each other and we have nothing in the front, you cannot have no numbers in the front, no numbers here, okay? What we can do is we can make this one big radical and just make it a fraction and put everything just under one big radical, okay? Now, what is 12 divided by 6? If I plug that into my calculator, because even though it looks like a fraction, 12 divided by 6 is the same as 2, right? So if we have the square root of, let's see, 12 divided by 6 would be 12 divided by 6 is 2 over 1, right? So this ends up being the square root of 2. Because really the square root of 1 is the same as 1, okay? Because we know that 1 times 1. So let me back up here a little bit. So if I do this, I can split out my fraction again and do this. And well, we know that we can't have a radical in the denominator, but this right here just becomes the number 1, right? It splits out. 1 times 1 is 1. It just becomes 1, square root of 2. So this answer is really just the square root of 2, okay? I'm perfectly happy if you go from this straight to here, okay? And just you find out when you plug in your calculator, 12 divided by 6 equals 2. So you still have the square root of 2. We don't have a radicand in the bottom. Okay, that was kind of the long explanation. All right, square root of 98 divided by square root of 94. Plug that in your calculator. What do you get? Well, It's not as simple, is it? So here's what you do. You can also do square root of 98. Let's split this up. Square root of 4. Hold on. Yeah, when I divide 98 divided by 4, I get a decimal, right? 24.5 if you put that in there. And so I don't like that. We can't take the square root of 24.5. So I'm going to split up my big fraction and make two smaller fractions. And here's the cool thing. What's the square root of 4? That comes right out. It's just the number 2. And then I have the square root of 98. So now I've gotten rid of my radical on the bottom. However, I still have to simplify my radical 98 on the top. So let's go radical 98 on top, split that out. We get 2, 49, and 7 and 7. So look at, I have this. So I have 7 on the outside, 2 on the inside, divided by 2. This is our new radical. All right, so I took this 2 right here, and it stays on the bottom, and we simplified this over here, and it became this right here, okay? Let's try one that has something a little bit more complicated. So look at 4 divided by the square root of 5. Now in this instance, we don't have a square root over both the 4 and the 5. So the 4 on the top, that is a whole number. We can't do anything else with that. That is as simplified as it gets, okay? So what we do now is we have to rationalize the denominator. This is like the next level here, right here. Rationalize the denominator by multiplying the top and the bottom of the fraction by the radical. And I'll show you what I mean here in just a second. Okay, so if I look at this question here, I'm going to get rid of, and you'll see how this works here in a second, I'm going to get rid of that radical on the bottom by multiplying root 5 times root 5. Now, you guys, what is Mrs. Baxter's favorite number of all time? If you said 1, you would be correct. Well, let's look at what's radical 5 over radical 5. That number is just 1, okay? It's just like saying 3 over 3. That equals 1. 72 over 72. That is the same thing as 1. And so what we're doing when we're doing this is we're kind of manipulating the math to make it work for our circumstances, okay? We are not changing the value or how much 4 over root 5 means. We're just getting rid of the radical, okay? Which means we're kind of like balancing our equation like we would in a multi-step equation. So talk to me here. We know our multiplication. I'm going to multiply fractions straight across. When we multiply the top across, we multiply the bottom across. Okay, when I multiply the top across, my outsides are 4 times 1, square root 5, right? Which is the same thing as 4 root 5. And when I do the bottoms, I do root 5 times root 5. So I'm actually, let me change that a little bit. I'm just going to do root 5 times 5. I'm going to do my insides, and I get square root of 25, right? Well, what's the square root of 25? Look at that. When we multiply a radical by itself, it just becomes that number outside of the radical. So this problem right here becomes 4 square root 5. I can't simplify this top number at all. It's done. It's simplified. But square root of 25 is 5. So this right here is my final answer, okay? I've just taken this number, thrown it down there, all right? Okay, I know this is a lot. Hang with me. We're going to keep building on it, okay? Now I've got a radical on the top and a radical on the bottom, but because I have a coefficient I can't just make one big square root. Nope, nope, nope. Can't do that. Okay, so now I'm going to have to rationalize the denominator by multiplying the radical on the bottom to both the top and the bottom. So watch what I do. I'm going to create the number 1 by multiplying square root 15 over square root 15 to this 3 root 2 divided by root 15. Let's see what that looks like. Okay, well, if I multiply my outsides, 3 times 1 square root 2, which is an inside, times 15, which is an inside, right? What do I get? Well, I get 3 root 30. Okay, that's on the top. Now, based on what we've learned about multiplying a radical by itself, like 2 times, root 15 times root 15, oh look, I have a pair. It just automatically becomes 15, okay? Because I can take this pair outside. Now, the question is can I simplify root 30? No, I cannot. I'll just tell you that right now. So my final answer is this, okay? All right, let's look at one more example right here, okay? I'm looking at this one and I'm thinking, I have a radical here, a radical here. I have no number outside. I have no number outside, right? So what I'm going to do is I'm going to just make it one big radical like this. I have to do maybe a 2-stepper. So this is how my brain is working right now. 6p squared. Now, I want to simplify this before I take the radical. I'm thinking here really quick. I think what I'm going to do is when you do 18 divided by 6, you're not going to get a nice number. But if you remember how to do the fraction function, you're going to go 18 divided by 6 in your calculator. Oh, actually, you are going to get a nice thing. I don't know what my brain's thinking. You guys, I have 4th, 5th, 6th block brain. 18 divided by 6 is 3, okay? And then if I divide my p to the 9 over p squared, it's really 9 minus 2. So this becomes p to the 7th. And I have this as a radical. I've automatically gotten rid of my denominator, okay? So if you want me to draw this out, I'll explain how this works. If I have p to the 9 divided by p to the 2nd, right? I'm really doing, I have 9 of them here. 4, 5, 6, 7, 8, 9. And I have 2 here, okay? These cancel each other out. And then I'm left over with 7 of them, okay? So that's how I figured that out. The shortcut is just p9 minus 2 when you're dividing exponents, okay? All right, I know this was a lot. We have a practice worksheet to do. Please get with a partner, somebody around you. Grab me and we will work through those problems. If you have a question or you're still not sure about some of the notes here, please reach out to me, okay? All right, ready or not, here you go.